welcome back everyone. I hope you had a great spring break. It was very long. We'll enjoy it. I wanted to apologize because I don't know why last week, no, like the last week we had class, it was 2 weeks ago, the week before spring break. I don't know why the videos didn't upload. I fixed that today. I don't know what happened, but the videos are there. Today we're going to start the last unit. So this is the last review I have. It's all about circles. They are not like the most important in the exam, but they are important. So we need to know them. Let's start. So triangle ABC is inscribed. Inscribed just means that it's inside something. Um, in circle O, segment AB is the diameter of the circle. Okay, if ABC, so ABC is 17.5. So this is 17.5. What is the measure of angle BAC? So they're asking for this angle. I'm gonna call it A. Now, you might be wondering, but we don't have the measure of this. But there is a theorem. Yeah, this is the bad part. You need to know this by memory. There is a theorem that establishes that all triangles that are over the hypotenuse that are inscribed, or like for example, this is a circle, this is the diameter. All triangles that are inscribed in a circle like this over the diameter, this triangle, this triangle, um, this triangle. Doesn't matter where you go, as long as the vertex is inside the circle, like is on the circle, and this part is the diameter. This angle will be 90 degrees. That's the theorem. So since this is the diameter of the circle, and this is on the circle, then this angle is 90 degrees. I can say that x plus 90 plus 17.5 is equal 180, because all that's from before. All angles in a triangle are equal to 180. So this the addition of the angles. So x plus 90 plus 17 is 107.5 equal 180, and x equal 170. Wait, what? We take 107 from both sides, and this equals 72.5. And this is our answer. I don't know what happened before, whatever. So here we are. Now here, point A, B, C, D lie on the circle, so they're on the circle, and E, on circle E, as shown in the figure below. What statement must be true about the figure? So first, we can say this is the diameter, because A and D and C lie under circle, and E is the center, and it passed through the center, so AC is the diameter. And because of what I said before, I know that angle D is 90 degrees, and I know that angle B is also 90 degrees. Just because of what I said from before. Now, let's see here. BCD. Okay, we have BCD here. BAD equal 90. No. ADC, okay. ABC equal 90. Yes, that's exactly what we said. Let's check the others. ABC, 90, yes. BCD, not necessarily. And then BAD is this one. ADC, no, not equal 90. So yep, that's our answer. Now, in circle M shown below, measure of D EF, so measure of the EF, is 5x minus 10. What is the value of x? So we know that this is the diameter because it's going from one side to the other of the circle. This is the opposite side, so this must be 90. So if I say that 5x minus 10 equal 90, I add 10 in both sides. So I have that 5x equal 100, since 90 plus 10 is 100. And then I divide by 5, and 100 divided by 5 is 20, so x equal 20. Let's continue. In the diagram, C is the center of the circle, and angle yxc is inscribed in the circle. Okay, which of the following statements are true? Answer it or apply. So Cx, so Cx congruent to Cy. Yes. Why? Because all the radius of the circles are are the same. Like if I draw a point, like if I draw a line from the center to any point on the circle, they will have the exact same measure. Example. Then I type take this. Oops. One, two. Okay, they all have the same measures, just that I'm dumb sometimes. Yeah, there you can see more or less. So all the lines, I can say that this equal this equal this. So yes, Cx equal congruent Cy. Now Cz and Xy, no. This is congruent to Xc, but not Xy. Xy is the whole thing, it's twice, it's the two parts, it's diameter, which is not what we're looking for. Also, we can say that diameter is twice is the radius twice, or the diameter is half the radius. And the diameter is just the one if going from one point of the circle to the other while passing through the center. Remember, this is just reviewing. If you need like a specific, you don't understand the content, please see me personally. I will explain the content overall. Also in the description, I always attach videos explaining a little bit of the content. Here I'm just explaining the exercise itself. So we have that. Now triangle CX C X Z. Okay, C X C isosceles. Isosceles just means that it has two equal sides, as you can see here. This equal to this because they are both the radius of the circle and the radius are equal. So yes, it is an isosceles triangle. Now XYZ, XYZ is acute. Okay, acute just means that is that the angle, there is acute and obtuse. Obtuse is that the angle is greater than 90 degrees. Acute is that is less than 90 degrees. So no, it is not acute, neither obtuse. Because what we said before, this is a 90 degrees angle. So this is a right triangle, neither acute nor obtuse. Now, xy is the diameter of circle C. Yes, xy pass from one end to the other end of the circle, passing through the center. So yes, it is a diameter. Now let's see number 5. In the figure below, AB is the diameter of the circle with center O. If ABC equal 30, so this is 30, and CAD, so CAD 140, where is BAD? BAD, okay. So what we can do is look for this angle right here. So we need to find this. So we can look for this angle right here first. We have all that we need. So this is 90 degrees. This is also 90 degrees because they're over the diameter. So I can say that 30 plus 90 plus, I'm gonna say x plus x equal 180. 30 plus 90 is 120. So 120 plus x equal 180. And we subtract 120 from both sides, and 180 minus 120 is 60. So this angle right here is 60. Now the two angles together, the one that we're missing here was, I'm gonna say y. So y plus 60, the two angles together, make 140 because that's CAD. So I can subtract 60 from both sides and I get that 140 minus 60 is 80. So that's my value. So BAD, this angle right here, equal 80. Sorry. Points AB and D lie on the circle D. Well, the circle is C, not D, but it doesn't matter. You guys can see it. Now determine the measure of the indicated angles given that A is equal 30 degrees. Enter the measure on the box. So BCD, angle right here, and ABD, ABD. So first from ABD, this is the diameter. So we know this is a 90 degrees angle. So this is gonna be 90 degrees. Now, want to know this one. To know this one is a bit more complicated. So let's first calculate this one. We can say 30 plus 90 plus x equal 180. 120 plus x equal 180. Then we subtract and x equals 60. So this one is gonna be equal 60. But we cannot do addition of triangle because we don't know this specific angle. So what we can do is first look for this angle. This is a process. So sorry. We know this is equal to this one because they are both radius. This one radius, this another radius. So we can say that triangle ABC is isosceles. So this is also going to be equal 30 degrees because of that. Now we know that the whole angle here is 90, so I can say that 30 degrees plus y equal 90. So y, which is gonna be this angle right here, equal 60. And also in dumb because the same analogy we did there, I could have done it here. This is a radius. This is also this is another radius. So if this is 60, this also must be 60. But sometimes we are dumb, including myself, like people. But it doesn't matter how we get to the answer. The important part is that we get there. So now we are looking for Z. I'm just gonna call it Z. So Z plus 60 plus 60 gonna be equal 180. So Z 60 plus 60 is 120. 180, and then 180 minus 120 is 60. So that's our answer here. Now, if measure of angle B is 3.5 times measure angle A, so I'm gonna say that angle A equal X, and then B is going to be, you know, B is going to be 3.5 times, so 3.5 3.5 is the same, 3.5 times A, so it will be 3.5x, and when I write this, is a complex number. So 2 times 3 is 6, plus 1 is 7, so it will be 7 over 2x. Or you can also say 3.5, half is 3.5, so 3.5x. What are the measure of A and B? So we say that this is x, this is 3.5x, and again, this is 90, so 3.5x plus x plus 90, 280. So 3.5x plus x equal 4.5x. And then 90, like 180 minus 90 is 90. Then we divide both sides by 4.5. And we have that x equal 20. And let me just rectify that. And yeah, equal 20. And now we're asking for the measure of angle A and B. So we know that A is going to be equal 20. Because A equal x. And then B will be 3.5 times 20 is going to be equal 70. Is exactly sure is D. Now, in the diagram below, quadrilateral PQRS is inscribed. Inscribed just means that it's inside the circle. And actually the vertex, which are the connection of the lines, lies on the circle. They lie on the circle. So find measure of P and measure of Q. So we have measure of P here, measure of Q. And this is all the information we have. Now, we can do a couple of things. Um, there are a couple of things that we can do to like solve for this. But let me first say something. Um, just to rectify one thing I didn't want to say before making sure it was true. But yes, there's a property. Yes, this is the bad thing. You need to know the property by memory. There is another way. And basically, opposite angles of a quadrilateral inside of a circle are supplementary. What does that mean? That the opposite sides, like the opposite angle, which in this case will be, for example, if I draw a straight line, so this is opposite to this one, they are supplementary, they add up to 180 degrees. So I can say that 126 plus b is going to be equal 180. So if I say 180 minus 126, it's gonna be 54, so b equals 54. And now here, wait, 100 plus s is gonna be equal 180. So if we subtract 100, we have that s equal 80. And that's our answer, which is choice A. Yeah, that's basically like you need to know that the in a quadrilateral that is inside of a circle, quadrilateral inside of a circle, the opposites angle add up to 180. They are supplementary to each other. Now, let's see 9. In the diagram below, quadrilateral WXYZ is inscribed in a circle. If W, okay, this is basically what we have drawn. And they're asking for the other side, we need to do the same. So we have a straight line, we're looking for the opposites, and we do the same here. Opposites. So 72 plus x going to be equal 180. So x will be equal 180 minus 72, which is 108. Now 94 plus y going to be equal 180. So y will be equal 180 minus 94, which is 86. And that's our answer. X 108, y 86. Now let's see this one. This diagram circle and in this diagram shows a circle and an inscribed quadrilateral with angles measured represented by expressions. So we have this expression for this angle and this angle, and if we draw a straight line, we're gonna see that they're opposite. So they add up to 180 degrees. And they're asking what is the measure of V. So first we need to solve for x, right? So we can say that 5x minus 1 plus 3x plus 5 equal 180. Now since we're adding, it doesn't matter, we can take away the parentheses because in addition, so I can say 5x plus 3x is 8x, and then 5 minus 1 is 4, 180. Then I'm gonna continue here. So 5x, 180 minus 4 is 176. And then 176 divided by 8 is 22. Let me make sure about that one. Yep. So x equal 22. Now they are not asking for x, they're asking for the measure of b. So here is b, and I can say 3x, which is going to be 22, plus 5 is going to be equal b. So 3 times 22 is 66 plus 5 equal b. And 60 plus 5 is 71, so b equals 70, which is right here. Sorry about that. Now 11. The diagram below, quadrilateral ABC, D is inscribed. Measure of angle A is represented. Measure of angle C is represented. What is the measure of angle A and angle C? Now, if we draw the opposite line here as well, we're gonna see that they are opposite, so they are up to 180, so 5. I'm gonna do it here at the side. So 5x plus 20 plus 6x plus 17. And since we're adding in the parentheses doesn't matter because we're doing an addition. So see if 5 plus 6 is 11, so 11x. 20 plus 17 is 37. This equals 180. Now 11x equal 180 minus 37, which is 143. And 142 divided by 11 is 13. Wait, let me check. 142. Yes, 13. And that's our answer for x, but they're asking for the measure. So here we have 5 times 13 times plus 20. Sorry, 5 plus times 13 is 65 plus 20. What is gonna be equal 8? 5 plus 20 equal 8. 5 plus 20 is 85. So 85 equal 8. And now for C, I can say 6 times 13 plus 17. 6 times 13 is going to be equals 78 plus 17, and this is going to be equal C. Now 78 plus 17 is 95, so 95 equals C, if I'm not mistaken, yeah. So A 85, C 95. So in the diagram below, imagine, yeah, this is the diagram. Quadrilateral ABCD is inscribed, circle O, measure of angle A, it is label, B label, C label. Okay, what is the measure of angle D? So first, we need to solve for X because we need X to solve for D. So we have the perpendicular lines and we see that 2x plus 15 equal 180. And then again, D plus X minus 10 equal 180. So first we need the X. So 2x plus X plus 15 equal 180. Again, we don't need the parentheses because we are addition. It is an addition. So for addition that the parentheses doesn't matter. Now 2x plus x is 3x, and then 180 minus 15 is 165, and then 165 divided by 3 is 55. So x equals 55. So I can say that D plus x minus 10 equals 180. X is gonna be equal 55, so it will be 55 minus 10, so it will be D plus 45 equal 180. Let's start from both sides and we get that D equal 135. And this is our answer. Now 13. In the line below, quadrilateral ABCD is inscribed in circle. Okay, quadrilateral inscribed as well. And we have the size label. If the following statements are true. Okay, we need to solve for X and for Y. First, let's solve for X. This is the opposite sides. They add up to 180. So for X plus 13 plus 8x plus 11 equal 180. For F4x plus 8x is 12x. 13 plus 11 is 24 equal 180. And 12x equal 180 minus 24 is 156. And we divide by 12. 156 divided by 12 is 13. So x equal 13. Yes. Let's see why. No. We have the value of x, so I can substitute here, for example, 5 times 13 plus 4. 5 times 13 is 65 plus 4, which is 69. Now here we have 7 times 13. 7 times 13, that's 91. Yeah. So we have 91 plus 5y. Now 69 plus 91 plus 5y going to be equal 180. 160, like 69 plus 91 is 160 plus 5y, 180. We subtract 160 from each side. We have that 5y equal 180 minus 160, which is 20. And we divide by 5 and y equals 4, which is not what they say here. Now we want the measure of angle A. Measure of angle A, we calculated before. It is 69. I did calculate it before. Now angle B, I haven't, so we have the value. So it will be A times 13 plus 11. A times 13 is 104 plus 11, and this is going to be equal 115, which is the value. No, see, I haven't calculated either, but I do have the value of y, so C is equal 91 plus 5 times 4, and 5 times 4 is 20, so 91 plus 20, which is 111. Now measure angle D. I haven't calculated before, for real. So we have 4 times 13 plus 13. 4 times 13 is 52 plus 13, which is 65. This is what it says here, so we got the right answer. No, 14. I think, wait, let me, okay, we have a lot to do. A lot that I don't know if we'll be able to, we need to be able to finish before the exam, so let's continue. Um, a superstructure is being created to stabilize a circular playground. The outline of the superstructure is represented as quadrilateral ABCD shown below. The park planner needs to know the relationship between the opposite angles of the inscribed quadrilateral to draw a blueprint for the structure, which is the following relationships are correct. So basically, we draw the right line and we see they add up to 180, the opposite one. So it's A with C, we have it here, and it is D with B, which we have here. The other ones are incorrect. A does not go with B doesn't go with C doesn't go with D, and D doesn't go with A. Now, let's see 15. In the diagram below of circle O, chords A, B, and CD intersect at E. If CE equal 10, DEED equals 6, AE equals 4, what is the length of EV? So basically, we can establish the relationship that this is to this one as this is to the other one. Like for example, let me say in another way. So basically what I wanted to say is that this like this is the chord, the complete line. So the one segment of the line times the other segment of the line equal the same, like one segment of the line times the other segment of the line. So I could say, let me take out this. I could say that 10 to 6, so 10 times 6 equal 2, 4. I'm gonna call it x for to make it easier. So 4 times x. Then 10 times 6 is 60. 60 equal 4x. And then 60 divided by 4, it is 15. So 15 equal x, which is EV. EV equal 15. Now, 16. In the diagram below of circle O, chord AV intersects chord ED. And we actually have that label here. If find the length of CE. Okay, wait. We do not have ED. Give me 1 second. Then below circle O, chord AV intersects chord CD at E. If AE, A, BE equal 9. Find the length of CE. Okay, here the keyword is bisect. As I have been explaining since almost the beginning, bisects mean that it is separating the other in two equal parts. So we can say that CE is going to be equal to ED. So we can say this is x and this is also x because they are equal to each other. So now we can apply the same theorem. So 9 times 8 is going to be equal to x times x. So 9 times 8 is 72. So that's equal x squared. So x equals a square root of 72, which is the same for CE. Like that's the value of CE. Now we can simplify that. If I get 72, I can simplify, say x equals square root of 36 times 2. And now the square root of 36 is 6. So x equals 6, a square root of 2. Now the last one. Yeah, this is gonna be the last one. So we are going to continue next week. So in the diagram below, of course, A, B, and C, D intersects, and they are giving us the value. So the E is 2x plus 8. AE is 4x minus 3. And EV is 4. So this is going to be, what is the value of x? Okay. Oh, and EC is 3. Okay, I knew I was missing something. So we say, okay, we multiply this, so 3 times 2x plus 8, then must be equal to 4 times 4x plus 3. So this is what we have. We do our algebra, so 3 times 2x, 3 times 2, 6, and we give the x. 3 times 8, 24, so plus 24. Then 4 times 4, 16, so 16x. 4 times 3, 12, plus 12. Now we subtract X from each side. Subtract 12. And we have this cancels out here. Cancels out here. So 16 minus 6 is 10. So 10x equal 24 minus 12, which is 12. X equal 12 over 10. And if I simplify that, x equal 6 over 5. Since 12 divided by 2 is 6, 10 divided by 2 is 5. This they are asking for. Okay, I must have done something weird here. Let me recheck. Have the 2x plus 8. I have EC, which is 3, EC 3, AE for x minus 3. Oh, here. This is supposed to be minus 3. Sorry about that. So here we actually, instead of subtract, we add 12. Now it does make sense. And then we have 24 plus 12 is 36. 16 minus 6 is 10. We keep that one. And then we say that x equals 36 divided by 10, which is the same as 3.6, which is in the options. Now we're fine. Yeah, be very careful. Like if you do the right thing, but you forget, you actually write wrong a sign. It's not that you did the calculation wrong. It's just that you write the exercise wrong. Yeah, you don't get the point. So that's all. Well, that's all for today. We did a good deal. We'll continue next week. Yeah, we're almost there. We're just missing 58 more exercises. But you guys are going to do great in your test, and I'll see you next week. Don't forget to ask me if you have any questions. Watch the video in the description if you need anything more.